Right, well, we have to differentiate this equation. It's got y and x variables in it. So I'm going to try and explain this in more detail than what you need to write when you solve it, just so that you can see how we actually solve it. So technically what we're actually doing is we're going to differentiate one side with respect to x, and we could put it like this. You wouldn't do this, but this is what we're doing. And what you do to one side of an equation, you have to do to the other side of an equation. So we're differentiating the left side with respect to x, we're differentiating the right side with respect to x. Now what happens is that differentiation gets distributed to every term in the equation. And we would end up with, let's differentiate x cubed with respect to x, let's differentiate y cubed, which we can't do with respect to x, and there's a product rule here. Let's differentiate 2xy with respect to x, and let's differentiate the dx8 with respect to x. And of course, if you differentiate 0, you get 0. You differentiate 8, you get 0 as well. So they're pretty easy ones. All right, the x cubed is easy as well. You differentiate x cubed, the 3 comes down, x stays the same, subtract 1, and we're good. All right, but this is where it gets a little trickier. We can't differentiate y with respect to x, so we break the d dx up into two parts. The other part is d dy of y cubed, because we can't y cubed with respect to y. All right, and for the next term, we've got a product rule because we have a variable times a variable. And so you know with the product rule, we're going to differentiate one variable first and multiply it by the other variable, and then add, you leave the first variable the same and differentiate the second variable. So if we do the x first, we're going to differentiate x with respect to x, which is pretty easy. It turns into 1. And we're just left with 2y. And then we're going to differentiate the other variable, which is y, with respect to x. But we can't do that. So we have to do the same thing that we've just done. So we have 2x, and I'm going to add a dy dx, and then a dy, and that is of y. So what we can do is we can differentiate y with respect to y, and of course that just turns into 1. And what this has done, 8 goes to 0, it's introduced a dy dx into our equation. And so if we keep working on the next line, we'll have 3x squared plus dy dx. And now we're going to differentiate y cubed, and we'll get 3y squared. Of course, we can do that with respect to y. Y is the variable. We're going to add 2y plus 2x times dy dx. There's another dy dx in our equation. And we can differentiate y with respect to y. It turns into 1, so we don't have to write it. We don't have to write the plus 0, but it does equal 0. So at this point, when we want to find out what dy dx is, we're going to collect the terms with dy dx, and we're going to throw every other term onto the other side. So if we factorize dy dx out, we will get 3y squared plus 2x. And if we put the other terms to the other side, we'll get negative 3x squared minus 2y. Okay, now we just divide by the brackets, and we will have an equation for the derivative dy dx, which is equal to negative 3x squared minus 2y divided by, let's put the x first, 2x plus 3y squared. And we're done. Right, on to B. When you have a question that seems complicated, you try and break it down so you can make some progress. Make some progress, you're going to get some marks. So it says the tangent to the curve at the point where x equals 0. So we know how to do tangents to curves, and all we know is x is 0. And the tangent at the point where y equals 0. So that's a different tangent. There are two tangents, one where x is 0, one where y equals 0. Intersect at the acute angle alpha. Find the exact value of tan alpha. All right, so let's do what we would normally do when we're trying to find tangents. We will find the point and we'll find the gradient. So we have the equation and we have the derivative, which is the gradient. And so we will just start and go, when x equals 0, can we find a point? So we put 0 into the equation. We'll get 0 plus y cubed plus, well, that will turn to 0, plus 8 equals 0. So y cubed is negative 8 if we take the 8 over, which means y is going to equal negative 2, because the cube root of negative 8 is negative 2. So we do have a point, 0, negative 2. And when x equals 0, we can put it into the derivative function to find out a gradient. So dy dx is equal to, when x is 0, we're going to be left with 2y on the top, and we're going to be left with, what is it? 3y squared on the bottom, 3y squared on the bottom. But we actually have a y value now because we just don't know the x value. We put the x value into the equation and we have a y value, so we can put the y value into the derivative as well. And we will get negative 2 times negative 2 becomes 4, and we have 3 times negative 2 squared. Negative 2 squared is 4, and 3 fours are 12. So we have 4 on 12, which is 1 on 3. Okay, so we actually, and it's worked out nicely for us, found the equation of the first line, because we actually know the y-intercept. The y-intercept is negative 2. So the equation is y is the gradient, which is a third of x minus 2. For the second equation, we're told that y equals 0, and we want to find a tangent at this point. So we do the same thing. We put y is 0 into the equation, and we'll get x cubed plus 0 plus 0 plus 8 equals 0, which looks very familiar. The 8 goes over, becomes negative 8, and we find the cube root of it, negative 8, and x is going to be negative 2 again. And so for the derivative, this time we'll try and work a little faster. dy dx, we know the point now. It's x equals negative 2 and y equals 0. So when we have we're substituting in, we can substitute both variables in. And we have negative 3 times negative 2 squared. Negative 2 squared is 4, and negative 3 times 4 is negative 12. And then we minus 2 times y, but y is 0, so there is no y. Well, it's 0, you're minusing 0. And on the bottom we have 2 times x. X is negative 2, 2 times negative 2 is negative 4, and we're going to add 0. And so we have the derivative of the other line, which is negative 12 divided by negative 4 is 3. Right, so the equation of the second line is not obvious, but we don't really need it to solve the problem. We want to find tan of the angle between the lines. Now, I know it sounds complicated, but let's just have a little think about what's going on here, and we'll work this out. So the first line, at negative 2, it's got a gradient of a third, and so it's going to be going up slowly. And the second line, we actually know it goes through the point y equals 0, x is negative 2. So this is the point. And it has a gradient of 3, so it's going to be going up steeply, right? And of course, we have our axes, x and y. Okay, so if you, that's like a very rough sketch of what we're talking about. So the acute angle is going to be that angle there. And we're calling that alpha, right? Because it's the acute angle. All right, the key bit of information we need to remember is that the tan of an angle with the positive x direction is equivalent to the gradient, which is also equivalent to the derivative, right? The gradient is the derivative. So if we call that angle B, and we know that's the line where the gradient is a third, for this angle, what we actually know is the tan of B is equal to a third, because tan is opposite over adjacent. The opposite is the change in y. Adjacent is the change in x. The change in y over change in x is the gradient, and the gradient of that line is a third. And so with the other angle, we also have an angle, and we can call that one, let's call it CD, let's call it just D, so we have a different variable. What we know for this angle D is that the tan of the angle D is equal to 3 because 3 is the gradient. Right, but we're trying to find tan of alpha. But knowing what tan of D is and tan of B is, D and B are related to alpha, and we can work out alpha by saying, well, the angle alpha that we're interested in is equal to D minus B. Because if you take the value of the angle D, you minus the value of the angle B, you're going to get the angle alpha. So in other words, what we're trying to find, tan of alpha, is equal to the tan of D minus B on our diagram. And we actually know tan of D and we know tan of B. So we can use the formula for the difference of two angles for a tan, expand that, and we can come to an answer. Right, so from our formula sheet, we have the tan of A minus B is equal to the tan of A minus the tan of B divided by 1 plus the tan of A times the tan of B. So if we use this, the tan of D minus B turns into the tan of D minus the tan of B divided by 1 plus tan of D times the tan of B. But we actually know the values for the tan of D and the tan of B because they are the derivatives, or they are the gradients of the line. And so we can say this has become 3 minus a third divided by 1 plus 3 times a third. 3 times a third is just 1, so we have 1 plus 1. Okay, so we have, what do we have? We have 3 minus a third is 9 on 3 minus 1 on 3 is 8 on 3, 8 on 3, and we're dividing by 2. But instead of dividing by 2, we're going to multiply by a half. Just can't divide when we're dealing with fractions. So that turns into the 2 cancels with the 8, and we're left with 4 on 3. And that's our answer. Tan of alpha is what we had to find. Tan of alpha is equal to 4 on 3.